Hello, welcome to Chapter 1, questions 14 through 18. Question 14. A major focus of this course is learning the investigative process, a process you use during the Mobius strip activity in problems 9 through 12. One part of this process is asking mathematical questions. Assume your teacher is thinking of a shape and wants you to figure out what shape it is. Write down 3 questions you could ask your teacher to determine more about his or her shape. So you need to write down 3 questions that you could ask. So if I'm thinking of a shape, how would you determine what that shape is? What are some things that you could ask? I'm not going to write these down, but I want you to think as to what are some possibilities. Think about the sides of the figure, the lengths of them, what kind of angles they have. So write 3 questions about any of those things that would help you identify what the shape is. Question 15. The shapes at the right are examples of equilateral triangles. How can you describe an equilateral triangle? Examine them and make at least 2 statements that seem true for all equilateral triangles. Then trace these equilateral triangles on your paper and draw one more in a different orientation. So the 2 statements I gave were 3 sides of equal length. So all of these sides on an equilateral triangle, they all have the same length. And they also have 3 angles of equal measure, so each one of these angles is also equivalent. So those are at least 2 statements that seem to be true for all equilateral triangles, and then I traced a third one that was in a different orientation than the 2 that are on the in the book. Question 16. Match each table of data below with the most appropriate graph and briefly explain why it matches the data. So on the first part of A, it says boiling water cooling down. So you can see the time would represent your X value and the temperature would represent your Y value. So the temperature starting at 100 and then going down from there. You can also see how it's going down. This one went down by 11, then 9, 8, 7, and then 6. So it kind of gives you an idea as to which graph would work best for that. Graph 1 is increasing, graph 2 is increasing with some gaps, graph 3 is actually decreasing, and the other 2 are slowly on 4 increasing, but looks like graph 3 would be the only one that is actually decreasing like that. So that looks like boiling water cooling down. Let's look at B, cost of a cell phone. So you have time in minutes. As it increases, the cost in cents is also increasing. So for each one of those, we're only talking about specific times because it says cost of a phone call. So for 1 minute, it's going to cost 55 cents. For 2 minutes, 75. 2.5, 75. So you can actually see that these two have the same output. Same thing for 5 and 5.3. So even if you're talking 5 minutes or 5.3, it's still staying the same cost. So that would be graph 2, where you can see this is called a step graph or step function, where it jumps up to the next price once you get to that next minute. And then on part C, growth of a baby in womb. So you have the age and the months, and then the length of the baby as time goes on. So for that one, you have graph 1, 4, and 5 left over. So, right here, think of how it's growing on each of these. First one you have 0.75, and the next one you have 1.5, and then all of a sudden it jumps up to 3.4 in terms of how much it's growing. So look at those differences, and then it's definitely not graph 1 because it's not linear. It's not going up at a constant rate. So is it more like graph 5 where it increases really quickly and then slows down? Or more like graph 4 where it starts off slow, increases really quickly, and then kind of, slows off a little bit again? And it appears to be graph 4. So this will be C. And don't forget, I'm kind of talking through this, but it wants you to briefly explain why it matches the data. So make sure you write that down as well. Question 17, solve for the given variable. Show the steps leading to your solution, and then check your solution. So we're also going to check each of these as we solve. So on part A, you have negative 11x equals 77. So we're going to use inverse operations. Divide by negative 11. 77 divided by negative 11 is negative 7. And now we're going to check our solution by plugging it back into the original. So what is negative 11 times negative 7? Does that equal 77? And as long as you're left with a true statement, then it is a solution to the equation. So that is correct. B, we have 5c plus 1 equals 7c minus 8. Variables on both sides, so we can get the c term on the same side by subtracting 7c to both sides. That'll get you negative 2c plus 1 equals negative 8. Then you can subtract 1 to get the constant to the other side. And then you can divide by negative 2 to solve for c. And that will give you a value of 4.5, 9 halves, 4 and 1 half. They're all the same thing. And we will also check by plugging 4.5 back in to the original equation and seeing if we get a true statement on both sides. So on the left side we get 23.5 when we simplify all that, and then on the right hand side we also get 23.5. So that is correct. On C we have x divided by 8 is equal to 2. So to undo that, we're going to multiply. Since we are dividing by 8, we're going to multiply by 8. And that is x is equal to 16. So when we go to check this, we're saying 16 divided by 8 should be equivalent to 2. And that is correct. And the last one, D. Negative 12 is equal to 3k plus 9. So we'll go ahead and subtract 9. Negative 21 is equal to 3k. We can divide both sides by 3 and get negative 7 is equal to k. And my 7 is starting to look like a 2. So k is equal to negative 7, and then plug that back in because we need to check our solution. So is 3 times negative 7 plus 9 equal to negative 12? Well, negative 7 times 3 is negative 21. Negative 21 plus 9 is negative 12. So yes, it does check. So those how we solve different equations for variables, whether they're variables on both sides, different operations, things like that. But also, once again, make sure you do check your solution. And number 18, calculate the values of the expression below. Show all steps in your process. So once again, some order of operation type questions. Got a couple different ones here this time, but still the same idea. So in part A, we need to do what's on top of the fraction first, working inside the parentheses. So then 3 times 8 is 24. 24 divided by 2 is 12. Part B, we have 1/2 times 14 times 5. So 1/2 times 14 is 7. 7 times 5 is 35. On part C, 7 squared minus 5 squared. 7 squared is 49. Minus 5 squared is 25. 49 minus 25 is 24. And then the last one on D, we don't have any grouping symbols on this one. So we're going to work from left to right, first doing all the multiplication and division in the order that it comes. So the first thing we're going to look at is the 6 times the 2. So 17 minus 12 plus 4 divided by 2. Then we'll do the division. So that's 17 minus 12 plus 2. And then work left to right with addition and subtraction. So 17 minus 12 is 5. 5 plus 2 is 7. So once again, doing some more finding the value of expressions by simplifying using your order of operations.